Alright everyone, so this is problem 2.10 out of Griffiths Electrodynamics. Before I get into solving this problem, I'd just like to ask if you wouldn't mind please liking the video and subscribing. I upload a lot of what I would say is helpful videos if you are somebody who is interested in learning physics and getting better at physics, as I post a lot of solutions to undergraduate physics textbooks. So I think my channel has a lot that you can learn from. So I think it's worth subscribing, and it's just a good way to support me. Okay, let's get into the problem. It says a charge Q sits in the back of the corner of a cube, as shown in this figure. What is the flux of E through the shaded side? Okay. Now the equation we want to use here is the surface integral of E dA is Q enclosed divided by epsilon naught. This is also known as just the flux, the electric flux. But there's a problem with this. This has to be a closed surface, which clearly this isn't, because our charge is on the corner of the cube. It's on the corner, then it's not in a closed surface. But we can imagine a closed surface. It's very difficult to draw. I don't know if maybe I should draw it on the picture or just try it on my own here. I guess I'll try it on my own. Writing this problem because I feel like you have to almost draw it to explain it. So there's our point charge Q. So essentially what we're going to do is that charge Q, that one over here, we're going to surround it with cubes so that it's at the center of a bunch of other cubes. So what I mean by that is we're going to add a cube here. We're going to add one over here. And I know it looks really bad, but we're going to add one there as well. Now it's almost centered, but it's at the bottom. So we're going to add some cubes below here as well. Yeah, I'm not very good at this, I would say. Actually really bad at it. I don't know. I hope you're kind of getting the picture here. And this will be another cubed here. And then there would be two on this side as well at the bottom. So that point charge is just completely surrounded by different cubes. But here's the important thing. Q is now inside a closed surface, and it's at the center of that closed surface. So what we're going to do now is we're going to count. The flux is going to be equal for all the sides that it goes through. So what we're going to do is we're going to count all the faces that we need to worry about. So we're going to have 1, 2, 3, 4, and then there'll be 5, 6, 7 there. And then let's see, we should have down here 1, 2, 3, 4, 5, 6. I feel like I'm miscounting now. 1, 2, 3, 4, 5, 6. There's 8 here. Then there also must be 8 at the bottom, so now we're at 16. But remember, we also have the top as well to consider. So we have 4 here. So we were at 16 with the side faces. Now we're at 20. We're also going to have, I know you can't really see it, but we would have 4 down here, so that takes us to 24. So this is probably just not helpful at all, my drawing. But hopefully you understand what's happening is we have 24 faces of, or 24 sides of cubes that our electric field is going to go through. And they're going to go through them evenly. So if we just want this one side, then our flux is going to be Q over 24 epsilon naught. So each side gets a 24th of the flux. It's kind of a conceptual problem, and my drawing's terrible, but hopefully you left this video with at least some of the concepts behind this. If it helped you at all, please leave a like and subscribe.